Hello, my name is Tyler Sprague from the University of Washington, and today I'll be presenting Saving the Green Lake Pool Structure, the preservation discussion of Jack Christiansen's first thin shell project. I offer this presentation as a case study and example of the preservation challenges facing thin shell concrete structures from the mid-century period. While this one is located in Seattle, Washington, certain elements of it are applicable to structures around the world. So here is the pool structure, photographed shortly after its completion in 1954. It is a single barrel vaulted shell, providing a clear span over a community pool. This pool structure was an addition to an older community center. The Green Lake pool structure is currently threatened by designs for a new and improved public pool and community center on this site. And while other projects clearly rally international support for their prominence and significance, their expressed details, smaller projects like this Green Lake pool have far less certain fate. With its simple, almost elemental form, it does not have those elements of expression and structural design that gather the interest of in other projects. And yet it holds the distinction of being Christiansen's very first shell project, the first in a long, globally significant career as a thin shell designer. Therefore, the preservation discussion is both about the physical building itself and the longer legacy of Christiansen's work and the international movement around thin shell concrete. Just a quick reminder about Jack Christiansen. He was a significant American designer of thin shell concrete structures. Christiansen found economy in easy to construct and reusable formwork systems. And this is what made thin shell concrete cost effective in the labor markets of the Pacific Northwest. He designed a variety of shell geometries, starting with a barrel vaulted form, including this long span airplane hangar for B-52 bombers and for the Boeing company. He was inspired by the work of Felix Candela and adopted the hyperbolic paraboloid later in his career, arranging these warped panels to create domed-like shapes with stiffeners along the peaks, creating these valleys and these shadows. His career is, of course, capped by the design of the Seattle King Dome, the largest freestanding concrete dome in the world. It was a large multi-purpose arena for the city of Seattle, bringing both the Seahawks, the Seattle Mariners, the Seattle Sounders, and providing a public resource for over 20 years. Christiansen's career contained over 100 projects, primarily in the Pacific Northwest, but indeed existing in places all over the world, from New Orleans to Minnesota, including one project in Saudi Arabia. And you can see the variety of forms really do describe his creativity in structural design. Which leads us back to the Green Lake pool itself, a rather simple structure, and yet it is the starting point. So understanding Christiansen's longer career helps us see this project with new eyes. Christiansen got his start by using the ASCE Manual 31, published in 1952. So this design guide provided a blueprint for how to design cylindrical shells. Christiansen was able to understand the guide. As you can see here, came up with his own methods for using the information contained in them. He developed the drawings for the shell, and with a mind towards efficiency already, detailed the reinforcing for just 1/4 of the shell on the far left, of course, taking advantage of the biaxial symmetry, and you can see the geometry definition in the lower portion there. The design guide did not describe how to build formwork or any sort of methods for economy in that. So this project is really where Christiansen started working closely with a contractor to come up with a precise wooden formwork system. And it is really where he learned the importance of reusing formwork for the economy of these shell projects. While this form was only used once and then discarded, virtually every other project of Christiansen, there was a reuse of formwork. So here's the project as it stands today in the middle of a Green Lake Park in Seattle. The building is in good shape with a durable exterior. Understandable waterproofing and mechanical upgrades have occurred over the time. And yet there is a new urge to improve the space. As with any building that's over 60 years old, Seattle Parks and Recreation has started looking into improving the assets of the park. They've hired a design team which assessed the current resources, and what they found through public outreach was that there was very little public appreciation for the structure of the pool. Some earlier designs called for the actual preservation of the barrel vaulted shell, but these were quickly abandoned. So the current designs are beautiful. They embody the current trends of sustainability with large open spaces, a wooden structure with all sorts of public amenities as a part of the improved pool structure. So the only public avenue that remains for the shell is the Seattle landmarking process, which does allow for the definition of a site to be declared significant by the criteria you see on the right. The ones that would apply to the Green Lake Pool include the significant associated with a significant person in the city of the history, embodying a distinctive visible characteristics of architectural style or method of construction. And part E, an outstanding work of designer builder, is close, and yet both we know it is the initial work of Christiansen and perhaps not his most outstanding one. Therefore, this project raises several questions. How can we as the IASS community better advocate for the preservation of these shell structures as hybrid works of architecture and engineering, when the value of a structure is not only visual or experiential, but in the experimentation or process of design? How can we describe the public benefit? This was Christiansen's first project. With more challenges coming, how can preservation be balanced with contemporary use? And I offer these as open questions surrounding the preservation of thin shell structures. All right, thank you.